Be classifying quadrilaterals in the coordinate plane. So what this amounts to is we will be given a set of ordered pairs that represent the vertices of a quadrilateral, and using the distance formula for the sides and for the diagonals, we will be able to determine whether the 4 points that were given represent a parallelogram, a rectangle, a rhombus, or a square. And that's going to be a big part of what we will be practicing today. So let's get started with some examples. So as I said in the introduction, the two things that we'll be doing, and we'll do them in this order. Step number one is we will check the congruency of the sides. And then we will check the congruency of the diagonals. And you have the 4 cases presented here. I think I'll just start walking you through some examples. You can refer back to these 4 cases, but I think you'll see as we do a few examples that this is not going to be a very challenging exercise. It's going to take a few minutes, but I don't think you'll find this to be too terribly challenging since you have already gotten a lot of experience with the distance formula. Okay, so given these vertices A, B, C, and D, I'll make a picture of a quadrilateral, and you can always, when you're doing this picture, just write your vertices like this clockwise, do it the same way. So what I want to do is I want to see the distance from A to B using the distance formula. So let's find AB. And remember, that's the difference between the two x's. So 9 minus 8 is 1 squared. And then the difference between the two y's, negative 4 plus 2 is negative 2 squared. And so you do your math here, and this is going to be the square root of 5 is the distance from A to B. Well, I know that for any quadrilateral, the opposite side is congruent. Okay, so if you just want to take a shortcut to this process, now let's jump to see if side AD is congruent to AB. All right, so let's find the distance from A to D. So we're going to do the square root of 9 minus 3, which is 6 squared, plus negative 4 plus 7 is 3 squared. So we get 36 plus 9 is the square root of 45. Okay, so right away we know this can't be a square or a rhombus. Okay, it's got to be either a rectangle or a parallelogram. So let's see which one we have. If it's a rectangle, then the diagonals will be congruent. If it's a parallelogram, the diagonals will not be congruent. So we're basically narrowed this down to rectangle or parallelogram. Okay, so let's take a look at the diagonal AC. Okay, so distance for AC, 9 minus 2 is 7 squared, plus negative 4 plus 5 is 1 squared. So that's going to be the square root of 50. Okay, now let's find dB. dB or BD, 8 minus 3 is 5 squared, plus negative 2 plus 7, also 5 squared. Square root of 25 plus 25 is 50. So we've proven that these diagonals are congruent. So we now know that this has to be a rectangle. So ABCD is a rectangle. Okay, and we're going to do very much the same thing on these other 4 examples. All right, so let's just do a little rough sketch of QRST. And let's just go ahead and find the distance for QR. All right, so -2 minus 1 is -3 squared. And -7 plus 5 is -2 squared. So that's 9 plus 4, so that's the square root of 13. All right, and TS has to be the same. So let's jump to QT. So for QT, -2 minus 1, -3 squared. And -7 plus 9 is 2 squared. All right, so we now know that this is either going to be a square or a rhombus because they all have the same sides, all 4 sides are congruent. But what's different is the length of the diagonals. For square, the diagonals will be congruent. For rhombus, they will not be. So now let's take a look at the diagonals. QS. All right, so QS, -2 minus 4 is -6 squared, and -7 plus 7 is 0, 0 squared. So that's going to be the square root of 36, which is 6. And now let's check TR. 1 minus 1 is 0 squared, and -5 plus 9 is 4 squared, square root of 16, which is 4. Okay, so we narrowed it down to square rhombus, but since the diagonals are not the same, it has to be a rhombus. And that's your answer for example number 2. All right, let's try number 3. So we have J, K, L, M. Let's find JK. 5 minus 8 is -3 squared. And -1 minus 2 is -3 squared. So that's going to be the square root of 18. And so let's jump to JM. See if we have congruency with all 4 sides. So 5 minus 8 is -3 squared. -1 minus 7 is -8 squared. So that's going to be 9 plus 64, which is the square root of 73. So we know that these sides are not the same. So we are either dealing with a parallelogram or a rectangle. And to know which, we'll check the lengths of the diagonals. So JL, -5 minus 11 is -6 squared. -1 minus 10 is -11 squared. And that's the square root of 36 plus 121, the square root of 157, okay? And then we'll check MK to see if they're the same. So 8 minus 8 is 0 squared. 2 minus 7 is -5 squared. So that's going to be the square root of 25. So obviously they are not the same. So this is going to have to be a parallelogram. Right, let's check out number 4. W, X, Y, Z. We'll check out WX. Negative 4 minus 1, negative 5 squared. Negative 3 plus 2, negative 1 squared. So this is going to be the square root of 26. Now let's check out WZ. WZ, negative 4 plus 1, negative 1 squared, and negative 3 plus 8 is 5 squared, and that's also the square root of 26. So we have either a square or rhombus. And depending on what we find out about the diagonals, so we'll start with WY. Negative 4 minus 2 is negative 6 squared, and negative 3 plus 7 is 4 squared, and that makes 36, square root of 36 plus 16, which is the square root of 52. And now let's see about XZ. 1 plus 3 is 4 squared, and negative 2 plus 8 is 6 squared. So we're going to get the same thing. So that means the diagonals are the same. So if all four sides are the same and the two diagonals are congruent, that means we have a square. All right. And we got one more of these, then we'll move to a different type of problem, and then hopefully you'll be ready to start the practice problems. D, E, F, G. We'll find DE. Length. Negative 5 plus 3 is negative 2. 9 minus 6 is 3. So 4 plus 9 is the square root of 13. That's DE. And now let's find DG. Negative 5 plus 8 is 3 squared, plus 9 minus 1 is 8 squared. The square root of 9 plus 64, which is the square root of 73. So we are dealing with either a parallelogram or a rectangle. And the diagonals will tell us which one. That's a terrible diagonal there. So let me see about DF. DF, length. Negative 5 plus 6 is 1 squared. 9 plus 2 is 11 squared. And that's the square root of 122. And now let's check out GE. Negative 3 plus 8 is 5 squared. And 6 minus 1 is 5 squared. So we got the square root of 50. So the diagonals are different measurements. So this has to be a parallelogram. All right, now the next type of problems, I'm going to do the odd ones in the notes, and then I'm going to give you the even ones as part of your assignment. So let's just walk through these odd problems. So on this parallelogram, PQRS, P is at negative 1, 6. S is negative 7, negative 3. So they want to know what is the slope of QR. Well, since these are opposite sides, they are parallel, they should have the same slope. So we have to do the slope formula. Oh, not the distance formula. we will do the slope formula, which is y2 minus y1 over x2 minus x1. And we got negative 9 over negative 6, which is 3/2. So the slope of QR will be the same as the slope of SP. Slope of QR is 3/2. Okay, on this rhombus, W is at -5, -2, and Y is at 3, -2. What is the slope of XZ? Well, they form a right angle, which means that their slopes should be opposite reciprocals of each other. So if we find the slope of WY, and we'll do the opposite reciprocal slope of that. So let's see what the slope of WY is. So Y2 minus Y1, which would be plus, over X2 minus X1. Well, this is a completely horizontal line because it has a slope of 0. And so that means that it's like saying 0 over -8 would be the slope, which is 0. Well, the opposite reciprocal of that would be 8 over 0, and you can't divide by 0. And we also know another way of looking at this is completely vertical lines have a slope that is undefined. So division by 0 is undefined, and all completely vertical lines have a slope that is undefined for that reason. So our answer for this problem is undefined slope. Right, couple more on this parallelogram. S is located at -4, 1. T is at 5, 3. What is the length of VU? All right, so if we find ST's length, VU is going to be the same. So let's find -4 minus 5 is -9 squared, plus 1 minus 3 is -2 squared. And so that's going to be the square root of 81 plus 4, which is the square root of 85. So VU length is the square root of 85. And we got one more. On this rectangle below, D is located at -1, -1. F is located at 4, -8. What is the length of GE? Well, since we're told that it is a rectangle, that means these diagonals are congruent. So if we find the length of DF, that will also be GE. So length of DF, -1 minus 4 is -5 squared. And -1 plus 8 is 7 squared. So that's going to be 25 plus 49. And that is the square root of 74. And that's going to be the length of GE. All right, and you'll be doing the same type of things. The only one that's a little bit different is number 8, and you'll have to use the midpoint formula, which I'll show you that again. It's the 2 x's of the 2 end points divided by 2. and then the two y's, same thing. Add the two y's together and divide by 2, and that will get you the ordered pair of the midpoint, which is going to be required on number 8. All right, that takes care of our notes for lesson 6.5, and if you have any questions, let me know.